So a nice perfect break. The ice break, we missed a day, but it didn't matter. Today's notes are provided notes. There should be a link in the folder today to find those notes and the worksheets. And yes, today's notes, if you're looking at them, they don't look like math class notes, right? Like on the front page there's not even a math problem. Like it's all words. What are we doing here? And what we're doing here is solving graphically. So today we're going to solve trig equations graphically. And we don't just mean like graph by hand, we mean graphically using a calculator. So a lot of today's notes, we'll do some examples on the second page. You see some actual math problems. But before we get to the actual math problems on page 2, we need to make sure we know how to work the calculator. And so this is really about the buttons on the calculator, how to use the calculator. And so that's why it's like, why do these not look like math notes? It's because it's more like calculator usage notes. But it's super important, especially next year for AP Calculus. It's very important that you know how to use your calculator. Half of the AP test is with a calculator, and you have to know how to use it and use it well and use it quickly. And so we start that right now. So number 1 there, all equations can be solved by which of the following techniques? Do you know? You might be able to answer it based on what we're talking about. Graphing, right? Factoring, you know that not everything factors. I mean, factoring is a sometimes thing. Completing the square, that works for quadratics. It does work for all quadratics, but it's got to be a quadratic. So algebraic techniques, that's a very broad term, but even as broad as that is, there's some things that just don't have an algebraic technique. Like you need to use the calculator to solve it. And so on the calculator part of the test, both our test and AP test, a year and a half from now for some of you, they can give you crazy equations as long as it's on the calculator part of the test, because then the calculator can do the answer or find the answer for you. All right, using a calculator. Make sure your calculator is in blank mode unless the problem specifies degrees. So the blank must be radians if the unless is degrees. And that second part, very, very rare that you would need to be in degrees. I mean, yes, we would specify it, but that's just kind of there because someone might eventually somewhere down the line specify, but not usually us. Yeah. All right, use algebra to get a 0 on one side of your equation. Okay, so you've done that before. That's part of factoring and completing not completing the square, but part of factoring is getting a 0 on one side. Put that side into y1. So now we're talking calculator lingo here. Put that side into y1 and 0 into y2. And kind of giving away the end point here, but we're going to find the intersections of y1 and y2. Your calculator can find intersections. So we put an equation in for y1, put 0 in for y2, and tell the calculator to find where do they intersect. Or, and I'm just going to go ahead and say this is not my preference, but it's a possibility, so you can do it this way if you want. Or, do not shift anything, meaning don't move anything around. Like leave the equation as is, and simply put the left side of the equation into y1, and put the right side of the equation into y2. And then here's why it's not my preference. Because if you do this, you will have to play with the window. The window meaning what you see, because if you put everything on one side, then all you care about is, well, where does it cross the x-axis? If you put one thing on one side and one thing on the other side, who knows where you have to look to see where they intersect. So it can be done that way. Not my preference. Part C, set your window. Speaking of windows. The window again controls like how much of the graph you see. The directions will tell you what to use for x min and x max. Like we could kind of start punching around on the calculator right now. We could just, doesn't matter what you put in for y1 right now, but if you go to window, you see an x min and an x max. The problem will tell you what those should be. It's not going to say find here's x min and x max. It's going to say find solutions on 0 to 2 pi. And so that means x min should be 0 and x max should be 2 pi. So it's not going to spell out what x min and x max are, but it's going to give you a shouldn't say range because that's y, but a span of x values to look through. And so that span is x min and x max. For the SCL, do you know what SCL stands for? Scale. That's like where the tick marks go. So in one sense, it doesn't matter at all what the tick marks are. And not in one sense. It does not matter what the tick marks are. But since we're doing trig equations, sometimes it's helpful to use pi over 4 or pi over 2 to help you see the graph. But it doesn't really matter what you use for the tick marks. This puts hash marks on those intervals. Number 3, for the y min and y max, be sure to include 0 if you set one side equal to 0. So as long as 0 is in between your y min and y max, you'll be fine. Now back to the not my preference thing. Continued why it's not my preference. If you entered one side into y1 and the other side into y2 without setting one side equal to 0, you might probably need to play with y min and y max to see where the two equations intersect. Because they may intersect at y equals 5,000 and you got to go find that. Or y equals negative 300 and you got to go find it. So it's much easier if you set it equal to 0, because then you're looking for the intersection at 0, and it makes y min and y max a whole lot easier to mess with. You can always change the window if you want to see the graph more clearly. So some people get really into fine-tuning their y min and y max so they see exactly what they want to see. It's like, well, as long as you can see where they intersect, that's all you need to see. If you want to see more of it, then you can play with it if you like. All right, stating the answer. Once we get that answer, there are, I'm not sure exact, I didn't write these notes, so I'm kind of filling in. Here's what I would put in that blank. Usually multiple solutions to trig equations. Not always, but usually. In fact, more than just multiple, usually there's infinite solutions to trig equations, right? You think about sines and cosines. You know, where do they cross the x-axis? Well, an infinite number of places. But number 2, most of the time the directions will tell you to find all the solutions from 0 to 2 pi. Right? Like one trip around the unit circle, find those answers. And then you can just add 2 pi to find all the others. The solutions to the equations will be the x values of the intersection points. the calculator will tell you the intersection points. You don't really care about the y value, you care about the x value. Number 4, use the intersect key, found by pressing second calc. So if you've got your graph there and you want to, I graphed x squared from 0 to 2 pi. X scale doesn't really matter, but I can put pi over 4. So I'm looking at some graph from 0 to 2 pi. But the second calc button, second calc, has tons of great features that you will use in calculus a lot. For us, right now, we just want to know where the intersection is. Calculus will start using some of these other ones.
Where's the calc?
Like dy dx is a derivative. Integral is the opposite of a derivative. So second is the top left button, and then second trace is what some people say it, because I guess that would give you the calc button. Second calc, and then intersect. Round all answers, so back to notes here. Number 5, round all answers to 3 places, unless told otherwise. That's an AP test thing. So we start that now. It doesn't matter a whole lot right now, but for the chunk of you that are taking AP Calculus next year, just get in the habit of 3 decimal places. Unless it says otherwise, 3 decimal places. Number 6, and then we'll do some examples. If you need to do something with your answers, like you solve the question or you solve the equation, but then it's like, multiply that by 10 or add the 2 answers. Like if you need to do something with them, use the stow button. Stow with a little arrow. You know what stow is short for? Store. So you're going to store your answer. The stow button on the home screen. Again, this is a little bit weird taking all these notes and then we'll use it. But so we use the store button to store the x value into an alpha letter. So you can save it as A or B or C or D or whatever you want to call it. That way you can use it later. To get to the home screen from the graph screen, press, you have a couple options here, clear or quit. Either one will get you back to the home screen. Once you're there, then you could press stow and then whatever letter you want to use. A, B, C, D, whatever. Okay, so that's a lot of things to think about without having actually done them. But if you turn the page, now we'll use that information. Definitely not a typical math notes kind of day, because it's basically how to use the calculator day. All right, typing powers of trig functions and reciprocal trig functions. I think we've talked about this a little bit in terms of if that's cosine squared, we don't want to square the 7x, you want to square the cosine. So you have to make sure that the cosine is being squared. So cosine, when you type cosine, it's automatically going to open a parentheses. And then you can do 7x and close the parentheses. But then you need to close that to make sure you square the cosine. There's some math programs, and maybe even fancier calculators, that as you open parentheses, it color codes them. So when you start closing parentheses, it's easy to see like which ones match. So it makes it a little bit easier to keep up with. If you have like 3 or 4 open parentheses, like, well, which one am I closing? Newer, nicer calculators and software will like color code them for you, so it's easy to see. These don't do that, so you just have to keep up with it. 3 tangent to the fourth of 5x squared. Okay, so what needs to get the 4 in this? What's being fourthed in this problem? The tangent. So I need to make sure the tangent of 5x squared gets the fourth. 3 tangent, open parentheses, 5x squared, close parentheses again to make sure we're fourthing the tangent. But the 3 is not getting the fourth. I don't know if this seems easy, but the bulk of the mistakes are made right here. Like, the calculator is going to find the answer. That's not the problem. The problem is, do you give your calculator the right information it needs? All right, secant. Well, there's not a secant button on the calculator. So what is secant? 1 over cosine. So you're just going to do 1 divided by cosine of x. Secant squared means we'll need to square the 1 over cosine of 4x. And you could square, I'm going to show it both ways. 1 over cosine of 4x squared. Or, because we know that 1 squared is the same thing as 1, you could only square the cosine in the bottom, not necessarily the 1 in the top. So 1 divided by cosine of 4x squared. That's the same thing. So it just kind of depends on how you think of secant. If you think of it as just cosine in the bottom, then maybe the second one makes more sense. If you think of secant as 1 over cosine, then maybe the first one makes more sense, but they're identical. So either one of those, whichever sort of makes sense to you. All right, some examples, some actual math here. Consider the equation 3 cosine squared x equals sine of 2x. Sketch the graph here between 0 and 2 pi. I kind of don't like these instructions because the graph of what? Like that's not a y equals. So I think I want to move it over to equal to 0. That's the method I'm always going to use, set it equal to 0. So I'm going to have 3 cosine squared x minus sine of 2x equals 0. All right, let's put that in for y1. Actually, I'll make sure I'm in radians before I go any further. Calculator defaults to radians, but if someone else has used the calculator, it might be in degrees, so you probably need to check. So 3, open parentheses to make sure I square the cosine, minus sine of 2x, close parentheses. Window, 0 to 2 pi is already there. I have pi over 4 as my scale. Y min and Y max, I really don't know what to do until I look at the graph. So I'm going to try -3 to 3. That's just a guess. As long as I include 0, I'll be okay. Let's see if that looks reasonable. Okay. I'm okay with that as a picture because all I'm looking for is where it's 0. So 1, 2, 3, 4 answers, and I can see the 4 answers. If I want to play with the windows, what we talked about earlier, like if I want to see up a little higher, then my Y max needs to be maybe 5. My Y min doesn't need to be so low. So maybe I switch it to -1 to 5. Then I can see the whole graph. That's not necessary. As long as you can see the 0, you'll be fine. again, some people go overboard with that. They're like, oh, I didn't need to go up to 5. I could have only gone up to 3.5 and only negative 1/2. I'm like, this is really overkill. But some people are going to enjoy like fitting their graph perfectly to their window. If that's you, knock yourself out, I guess. Don't spend too much time on it because the goal is to find the solutions, not to have a perfect picture. All right, sketch the graph from 0 to 2 pi. Now it just says sketch, so I don't need to be perfect here. Let's see. Again, is that exactly what's there? No, but the idea is there's 4 answers. There's 4 places where it's equal to 0. Oh, in fact, that's question. Oh, there's 2 questions. Question A's. Sketch the graph. How many values satisfy the equation? Well, 4. It crosses the x-axis 4 times. All right, now for the fun part. You know what? What haven't I done yet that I need to do if I want to find an intersection? I need to put in 0. Right now there's nothing for it to intersect. So I need a second equation of y2 equals 0. So y1 equals your main equation. y2 equals 0. And it feels like it doesn't show up because it's right there on the x-axis, but that's fine. Second calc, I want the intersection. If you remember that far, the calculator will walk you through the rest of the steps. So I want an intersection. First curve, question mark. So I can pick which curve I want to be the first curve, but if you've only got 2 in there, don't press anything. It defaults to the first curve being y1. So press enter. Second curve, question mark. Well, let's use the second curve, y2. Again, it defaults to the right one, so we'll just enter again. And then guess. Now this one is important because there's 4 solutions, and I need to get close to, like whatever solutions it's closest to is the one it's going to give me. So I need to move my cursor over, preferably we want them in order, so over toward the first intersection. So I'm going left, right with my cursor. I press enter, and the calculator thinks for a minute. And my first x value to 3 decimals, 0.983. And then I need to do the same thing. And here's where getting too cute with the windows sort of messed me up. I'm going to change my ymin back to something else so that it's not in the way of the words down there. Okay, same steps. Now I'm aiming for this second intersection. So second calc, intersect. Again, first curve, second curve, but those default to the right things. If you've only got 2 curves in there, it's not a problem. Later in calculus or later in math, if you've got 7 curves in there, then you be careful. Am I looking for y3 and y5 or y2 and y6? We only got 2, so we don't have to worry about it. First curve, second curve, guess. It's a little easier when I can see where I'm going. So get reasonably close. The closer you are, the quicker the calculator guesses, but it's so quick. Like, what's the difference between 1/10 of a second and 2/10 of a second? 1.571 for my second intersection. All right, I'm going to press pause, and you're going to find the next 2 intersections to make sure that you can do it. So, check those answers, 4.124, 4.712. Number 2, consider the equation 2 sine cubed of 4x equals 3 cosine x minus 1. So yes, you will have a calculator on this test because I don't know how else you would begin to solve this question. How many solutions are there from 0 to 2 pi? I have no idea right now. Let's move things around here. In fact, I'm even going to move things around and sort of write it in the calculator format. You don't have to do that, but if that helps you put it in the calculator the right way. It also doesn't matter which side you move it to. So usually I move stuff to the left, but I guess there could be an equation where I'd move stuff to the right. And now clear y1 and type in your y1. Careful with the parentheses. Again, whenever you hit sine or cosine, it automatically opens a parenthesis. So you got to be careful in the calculator that you close it. My window's 0 to 2 pi. Beyond that, I don't really care. Like, it doesn't really even matter if I see the whole solution or not. What's that? It doesn't look normal? Well, it does. It looks weird because something's cubed in there. So yeah, that definitely is an unusual picture. Yours might look a little different depending on what your window is. And if you wanted to see the top, you'd have to go expand your window. I don't want to. In fact, actually, I think I want to zoom in a little bit because I need to know if that's one solution or two solutions right there. So instead of seeing the top, I'm actually going to change my Ymin and Ymax to -1 to 1. It means I won't see the whole graph, but it means I'll get a much better view of what the solutions are. Oh, in fact, there's what I thought was a solution over here was not a solution. And I wasn't sure if there was 1 or 2 here. There's 2. So 1, 2, 3, 4 total. In fact, that's the first question. How many solutions are there? 4, but I wasn't really sure of that until I tweaked my Y window to make sure I could see where things were crossing or not crossing. Again, my window right now is -1 to 1. And you can always go -1 to 1. You won't see all of the graph, but you don't need to see all the graph. What you need to see is the intersections. Uh-oh. Let me make sure this is right. 2 sine of 4x cubed minus 3 cosine of x plus 1. There we go. Again, the calculator's not going to make a mistake. It's only going to be us if we type something in wrong. Olivia?
How do you know how far to go to look for how many solutions are within 2 pi if you can't enter 2 pi as the x max?
Oh, you can enter 2 pi as the x max. X max, like that doesn't look like 2 pi, but you can still type 2 pi, and then it changes it to 6.28 whatever. So you can type 2 pi in for x max. And x scale, you can put in pi over 4, and it'll change it to whatever pi over 4 is, or whatever decimal approximation it wants to use. What is the sum of the 2 smallest solutions? Okay, that's an interesting question. So second calc, intersect. Again, first curve and second curve should default. And then guess, well, I want the 2 smallest ones, so okay. 2 ways to do this, because I need to add the 2 smallest ones. And I need to be careful that I don't round to the end. So the 2 ways are use the calculator for everything. And the other way is to write them down, but write down more than 3 decimals. 0.333106. That's overkill. But I want to make sure I'm right to 3 decimals after I'm done with all the things I'm going to do on this problem. Let me show you how to do the store thing, though, because that will be most accurate. Oops, can't do it there. Uh-oh, I messed it up. Now I got to go back and do second calc, intersect. In fact, the direction said go to the home screen. So clear, quit, and then I want to store, and I'm going to call it A just because that's the first, so alpha A. And now in the calculator, it knows that A is 0.33, and I don't have to write all those decimals down.
My calculator won't let me get past the second term. Like, I keep pressing enter, and it just won't.
I'll be over there in a second. So next job is find the second intersection, call it B, and then add A and B together. Show my previous answers there. A and B, add them together. This looks awful, but the calculator does all the ugly work. So 4 cosine 3x plus 6 cosine 2x. I'm just doing it all in the calculator now. Minus 3 plus sine of x, careful with parentheses, plus cosine of 2x, but make sure I square the cosine. And who knows what that's going to look like, but I don't really care what it looks like. My y window is negative 1 to 1, so I'm really not seeing much, but I don't care. All I care about is where it crosses the x-axis, where it intersects with 0. 1, 2, 3, 4 times. Find the product of the values. So I got to find the 4 values, and then I will multiply them all together. So that's kind of just a pain. It's not really difficult. But this would be a great case for, and the reason this one's on here is you don't want to do this one by hand. You don't want to type out all those and then type them all back in. Like, you want the calculator to do that for you. I don't suppose you even have to find them in order, but it would probably be the best way to go. So store that first one as A. You don't have to write these down, but I think it might be helpful just so you keep track with what you know and what you don't know. And then when you get to the end, all you got to do is A times B times C times D. Today's assignment, I need to pass out the worksheet, is worksheet 1, and it's very calculator heavy. So it's not difficult, but it's definitely calculator heavy to get you used to working with the calculator.